Hello everyone, this is Mrs. Lindsay again. Now we're continuing on with factoring page 2. Again, please try these before you just watch the video. And again, if you get the hint for how to do a certain problem, and then still try them on your own and come back if you need to. Okay, so I'm going to highlight what's in parentheses here. So if I was just looking at y squared minus 9, hopefully you realize that that is a dots problem. Right? Okay, so you look at it as a quantity. This is a perfect square, and this whole thing is also a perfect square. So this, again, is a dots problem. Okay? So what's the square root? That's kind of the thought process. We don't ever write this down. The square root of the first term, well, that's x squared. That's what goes in the first spot of each of those. What's the square root of the second term? Well, the square root of the second term just happens to be a quantity. So again, what's the square root of it? Just like what we did here, these will cancel, and now it's a binomial. So y squared minus 9 goes in each of those spots. Okay. Difference of two squares, one's positive, one's negative. So just like we did in our previous problem, if you would like, you can distribute that through. Now, some of you might be saying, well, can I factor this again because it is a dots inside? Well, we got to be a little bit careful here because now this first term is a trinomial. That won't factor. And when I bring through this, this is also a trinomial. It doesn't factor again either. So this is simply your answer. Or you could leave it as the original as long as you have, again, parentheses around that y squared minus 9. Okay. All right, so moving on to number 7. Number 7 on this one is a more traditional type straightforward factoring problem. The only thing I would recommend doing, well, there's actually two. I would rearrange the order in descending order. I'll do that first. And then I would always, if that is negative, the leading term, I always factor it out. You don't have to. It just definitely makes life easier. Because especially if this is a factor of 1 here, even if it's not, it makes life much easier. Factors of negative 56 that add up to 1, that would be 8, and negative 7, and then you're done. So a pretty fairly straightforward factoring a trinomial with a leading coefficient of 1. Okay. Looking at number 8. Now this is actually two terms. This whole thing is a term. This whole thing is a term. So they actually have something in common. X plus 1. So that is my GCF. I'm going to factor out an x plus 1. Well, if I take it out of that first one, what am I left with? X and 4x minus 5. If I factor it out of this second term, what am I left with? Again, that's gone. Negative 6. Now it's just a matter of, I'm going to rewrite these as parentheses now instead of brackets, same thing. Distribute through. Now we've got a nice little trinomial here. Is this going to factor? Probably. Whether you do split the middle term or not. If you go right to kind of a guess and check method is what I call it. Again, factors of this are either going to be 4x and 1x or 2x and 2x. I'm going to start off with 4x and x. All right, factors of negative 6. And sometimes it's helpful to write it down. Here are my factors. And notice there's 4 of them because I can switch which number has the negative on it. They have to add up to negative 5x. So remember, I have to check the inner and the outer of FOIL. I know FOIL is kind of an older term, but if I redistributed this, I had come back up with this answer. Well, doing the 2 outer terms and the 2 inner terms add up always to the middle term. So that's why I kind of always look at these 2 terms here when I'm going this route. Okay, so I don't know, let's just try 3 and 2. Well, I can even try this, right? So I get 12 and 2x. Well, that's not going to work no matter where I put the negatives, because I'm either going to get 14x or 10x. So nope, that one didn't work. But I could also just switch the spots. can put 3 here and 2 here. So now I get 8. Oh, sorry. Yeah, 8 and 3. Yeah, that'll work because I either add them both together or subtract 1. Well, I need this to be a negative, so I want -8, and I want to add 3. So that right there is my answer. And again, you're welcome to do split the middle term if you're much more comfortable with that. That's absolutely fine. Okay. Moving on to 9. Again, here we have 3 terms, so I'm probably just looking at trying to factor. This leading coefficient, excuse me, is 1. So I'm just going to break that up into a squared and a squared. Again, this is 1. Factors of 1 that add up to -2, well, that would be -1 and -1, but now I just have to include the b squared with it. And it's absolutely fine if you drop this 1. So it'd be a squared minus b squared, a squared minus b squared, and then hopefully you see both of these are dots. So it'd be a minus b, a plus b for the first one, and then repeat it again for the next one. And again, you're welcome to leave it that way, or if you'd like to clean it up just a little bit, it's those 2 terms squared. I'm actually going to go ahead and move on to page 3 here. All right, this is a grouping problem. It's a 1-3. It's already set up for you with the parentheses, so that's nice. But I'm going to look inside the parentheses here, and I'm going to factor that. That factors, I have factors of 9 that add up to -6, so that'd be -3, y minus 3 quantity squared. And again, this turns to a dots. So it'd be x in the first spot. And then the square root of that would be simply just y minus 3. One of them needs to be a positive, one is a negative, and again, put those parentheses around there. So this is very similar to the problem we just did in the first page, problem number 3. Distribute through that negative, and you're good to go. Okay. The next 2 problems, 11 and 12, these are fairly straightforward split the middle term or factoring problems. I'd like you to go ahead and just pause the video on both of these. I would like you to try them and then push play when you're ready to look at the work. Okay, I went ahead and did split the middle term here, even though I typically don't do that. But that is the work over here, so you can see the middle term is split into -4x and 15x. And then also number 12. I also did split the middle term, and again showed the work over here for the factors that it would split into. Actually, I did not write down. I apologize, but that would factor into 15x, like I have written here, and -16x. And there's your final answer for those. Okay, so let's take a look here at number 13. So if we look at the terms here, there are 4 terms on this one. Looks a little bit like a grouping problem, 2 and 2. So let's go ahead and just try that. Group these together. Well, hopefully when you look at this, you see there's no like terms. However, it's a difference of 2 squares. It's a dots problem. Well, if I factor that into the dots problem, again, I'm simply just doing this portion here. That factors into 2x plus 5y and 2x minus 5y. Now I have my other portion of my problem, which I'm looking at here. That's this. So again, these are 2 terms. This is my first term because this is a multiplying right here. This is a term, and this is a term. Well, this is what's in common. So I can factor that out. So if I factor that out of this first term, that goes away, and I'm simply left with the 2x minus 5y. If I factor that out of here, again, that goes away. Well, it doesn't turn to 0. Anything divided by itself is going to be 1. And then that is your answer for number 13. Okay, and we have one more problem on this page. That is number 14. This one is a fairly straightforward trinomial problem with a leading coefficient of 1. Go ahead and push play on this one, and when you're ready to check your answer, resume to check your answer. Okay, so this one, again, with the GCF, or pardon me, a leading coefficient of 1, it's only factors of negative 48, that up to negative 2, which would be negative 8 and 6. Okay, so that concludes page 2 and 3. If you'd like to see page 4, you can go to the next video.